Hi class, I'd like to do a review of our last activity. It's called Ohmball. There's my cat, Jesse. Um, he's a chonker. Come here, chonker. She's a good chonker. Um, get on that chonk. Yeah. So anyway, Ohmball is an activity. I usually pass tennis balls around the classroom. It's really engaging. I'm sorry you guys missed it really. But the tennis balls represent electrons, and that's what you're going to see here moving around the wire. Elijah, would you close the door, please? So in this activity, we're exploring a couple different concepts and new terms. One is voltage, and there's current, resistance, and then we're talking about series circuits and parallel circuits. Your enigma, the big question at the beginning of this lesson, was why is that one circuit brighter than the other if they're only just configured in a different way? Same light bulbs, same battery, same wires, but one is much brighter than the other. So you get a chance to see that. And hopefully the activity took you through that and you understand it now. But in case you didn't, that's what this video is for. If you feel like you're all on top of it, please skip past it. If you did have any questions, if you're a little confused on what voltage or any of those terms are, please continue listening and watching. So connecting up a circuit with just one light bulb was the first activity. We start to see that the electrons are moving around in that kind of circular path. And by clicking the battery here and increasing voltage, you'll see that they're moving faster. So voltage is not how quickly the electrons are moving. My cat is just walking. Thank you, Jesse. Move. Okay. I don't know what he changed. Okay. Voltage is not just about moving electrons. A higher voltage from the battery does move them faster, but the speed of the electrons is something else I'll talk about in a minute. It's called the current. But voltage is also something called potential difference across the battery. It's like a potential energy. It's like a hill. The steeper a hill is, the faster a ball will roll down it. So a higher voltage battery is like a steeper hill than like a bunny slope of a low voltage battery. So here 40 volts would be like a steep hill. So those electrons move a lot more quickly than a shallower, like a bunny slope hill, if I move that voltage down. So voltage is really like electrical pressure, electron pressure. If you turn on a water faucet, just a little bit, a little trickle of water comes out. It's like a low pressure. If you open up that faucet so that a lot of water comes out, that's like a high pressure. It's like a high voltage. So that's what a battery does. It's like it's kind of like water pressure, except it's electron pressure. The more pressure, the faster things tend to move. Then we have this little thing called a light bulb, and it is also called a resistor. It resists flow. If I do click on that light bulb and increase resistance, you'll see that the flow of the electrons slow down. Now there's another way to increase resistance in a circuit. You need to get this back down to 10. I want to make sure all the light bulbs are the same. Yeah. I can increase the resistance in the circuit here by adding another light bulb. So I'm going to break that and add another wire here. So now there's two light bulbs in this circuit. Go ahead and complete that. And you'll notice the electrons are moving more slowly. So what happened here is that the flow was affected by a second resistor. There's more resistance in that circuit. You might remember from our wire resistance lab, the higher the resistance in a wire came from a longer wire or a thinner wire. But here we're adding little thin wires to it. The little filament in a light bulb is a very, very thin wire, so there's a high resistance from that wire, and it's going to slow down the flow in the entire circuit. So adding a second resistor slowed the current. So that's the third vocab word I want to talk about is electrical current, is the speed or the flow of electrons. It's like flow of water in a river. So adding more resistance to this river is like throwing a bunch of rocks into that river. It's going to slow down the flow, so it can't flow as quickly. So there's a lot of analogies And that's going to be a theme in our next lesson. But there's a lot of analogies between electrical circuits and those quantities and other systems like rivers out there that we've experienced in our lives. So this is a series circuit, and I can add other things. I think there's a few things in here. Maybe if I add a paper clip, let's try adding that. Let's see what that does to flow. It didn't change the flow too much. It won't let me change the resistance. Okay. Now this doesn't have much anything else. A hand and a dog. I don't know if we want to get those into it. But let's say if we add a third light bulb, that will slow down the flow again. Did I turn off? I don't know what I did. Maybe there's no voltage. Let's try that. It's not happy for whatever reason. There used to be a play button on this thing. Oh, well, let's try it again. Bleh. I had this all set up. Whine. Sob. Okay. Let's try this. Sorry, class. And make this last connection. Okay, we're working again. So now with three resistors in there, it's much more slow. Much slower. Now, I do want to go back to, keep on hitting the wrong button there. I want to go back to 2 light bulbs. There's the flow. I'm going to increase that a little bit, back up to 40, just a little bit more action there. We can see things better. Okay, so there you get a sense of flow. I can actually measure the current with an ammeter that gets a number, 2 amperes. So that's the speed of the flow. So remember 2. And that's with 2 light bulbs in it. Now I'm going to keep those same 2 light bulbs, break that circuit, but instead of lining them up in series, I'm going to line them up in parallel. Now I want to talk about that word series for a second. If you've watched a television series, not all TV shows are series. A true television series has an order of events, a flow to the story. So if you watch anime, or if you watch a TV series that has an ongoing story, Walking Dead would be one of those, for example. It's a bad example, but anyway, that's an example. Whereas if you've been watching any Seinfeld reruns, Seinfeld is not a series because each episode is its own story. It doesn't follow an overall theme or overall storyline from show to show. But something like The Walking Dead would. That comes from a comic book, which does have an overall flow, an overall theme, and an overall story. The World Series is also an example of a series. You can't play game 6 before playing game 2, 1, 2, 3, 4, and 5. See, the whole series might get won in 5 games. You might not have to play game 6. So series means in a single row, and that's what we saw. With these 2 light bulbs in series, there's only one path for electrons to flow. They have to flow through the one light bulb and then through the other. Now if I break that, okay, and I introduce a second path, I can't talk to that. Wow, look at that. Did things slow down? You'll see that the electrons are moving quite quickly through this battery now, and they split. If we slow down the motion here a little bit, I'm going to slow down the voltage, slow down the electrons. Look at how these electrons, so they go one way and then another, and one way then another. See, a single electron can't go both ways. They either go in one path or the other. But if we move that back up to 40 volts, just like when those light bulbs were in series together, and now measure the current, it's at 8 amperes. What happened to the flow? by having two pathways, it's like two lanes on a road as opposed to one. More cars can get through on two lanes than on one. Likewise, more electrons can get through in two lanes than on just one. But that also means this battery here is pumping out a lot more energy. It's doing a lot more, so it's going to run out 4 times more quickly than if those two light bulbs were in series. But also look at what's happening to these light bulbs. They're super bright. They're very bright, which means they're pumping out energy rather quickly. Now the flow in each branch, look at that, 4 amperes in each branch. That totals 8. So those electrons are splitting up exactly in half in numbers. And so the flow is less in each arm, but faster through the battery. So because we added these resistors in parallel, the flow is much quicker. So I hope that explains why those light bulbs are much brighter when they're in parallel than when they're in series. Also, our homework assignment asked you whether or not our house is wired as a series circuit or a parallel circuit. Now, if you turn out a light bulb in your house, turn off. Do all the other light bulbs stay on? They certainly do. And that's for a parallel circuit. Now, for a series circuit, if you turn off a light bulb, or if a light bulb blows out, what will happen to the other one? Will it continue working? Let's make a very simple series circuit here, not to waste time. All right, so here's our two circuits. Let's pump this back up to 40. Pump up the voltage. All right, there we go. There it goes. So there's a good comparison side by side. Same voltage, same light bulbs, same wires, but much different results. Now to get back to it, if a light bulb blows in your house, does it blow out all the other light bulbs? I think not. But also think about, as we add more and more light bulbs in series, what would happen to their luminosity? So that's another clue that our houses are wired in parallel. I hope this is helpful, and I want to end on one last note here. I'm going to switch over to my paper can, turn off the circuit, and turn off my paper. Okay, well, my paper cam's not working. Oh well. I don't know why it's not working. Perhaps it has paused its view. Let's try this. Well, it doesn't want to work. Anyhow, I'll get to the V equals IR later. That's something you should try out. That's what I was going to talk about. But voltage equals current times resistance is something we'll talk about in our next lesson and in the coming days a lot more. So hope you guys are feeling well. Be well. Stay inside. Don't go out. I heard a lot of people are telling you that. But miss your class, and hope to see you again before the end of the year.